Good afternoon, everyone. Today is about explaining to young people what a career in engineering is about, hoping to inspire you either to take up a career in engineering or, if you've just started one, to expose to you the many opportunities that are available. And I've been listening carefully to the speakers before me this morning and really empathising with a lot of what they say. I'm primarily a civil and structural engineer, but I've done nuclear engineering, mechanical and various other things throughout my career. And it was very interesting listening to them. Most of the people are young people and they're full of enthusiasm about how they've started off their career. I'm possibly the exception. I've been working now this is my 50th year at work. It might be 49, but it's near enough 50. So I've had a very long career. And the transformation that have taken place in my lifetime have been unbelievable. I was quite heartened in some way to hear the railman telling me there was a future in railway engineering for me, even at my advanced age, but I think perhaps he was being a little generous in his description because even though I'm enthusiastic about rail, perhaps I'm slightly too old to start up yet another change. However, many of the things that people talked about this morning were very important. First of all, there was the man who talked from Cisco, and when I started work, there were no computers at all. The only tool I had was a slide rule, a pencil and a rubber. When I started work, railways were still steam. I think diesels had come in and electrification followed afterwards. The only aeroplanes that were at Manchester had propellers, and travel was a luxury only for exceptional few. The gentleman we've just heard talking about European, I heartily endorse that. I haven't worked in South America. I haven't worked in every country in Europe, but I've worked in a lot of them. So the opportunities that engineering give you to work in lots of countries, to meet lots of people, to do lots of exciting things, are absolutely phenomenal. And what I can tell you from my perspective of 50 years is that not only was there a great past, but there's a great future. There's a great future because the challenges that we face are enormous, and the only solutions are going to come from the engineering community, and they're not going to come from my generation, they're going to come from your generation. So you have an enormous responsibility, an enormous opportunity, and a great possibilities in your career. Now, just to highlight that, what I'm talking about from the perspective of the Manchester Association of Engineers, which was started in 1856. It's probably the oldest institution represented in this hall today. And the reason that started, if we go back in time slightly, that Manchester has a good case for being not only the centre of world engineering, but the historical centre where engineering was developed, engineering was invented, and engineering spread out from here across the country and across the world in the Industrial Revolution. Not only in Manchester, but in this very spot. If you look over the road here, some of those original buildings on Chester are from the Industrial Revolution. And that Industrial Revolution was sparked by the development of water power, which promoted the demand for machines. Those machines promoted the demand for machines that would make machines, in other words, machine tool technology. That developed into a demand for better transport, which led to the canals, which led to the railway system. Steam was invented, so people put engines, created engineering. The first railway works were partly in Manchester, down the road here, now closed. The first railway in the world was built here. So this has a tremendous record of engineering and providing careers and providing opportunities for the rest of the world. But the important thing about it, one of the important things about it was that the engineering that was developed in Manchester changed the lives of everybody in the world for better. The productivity that changed in the Industrial Revolution through these machines was phenomenal. And that in turn led to the issues that we had over the century, the globalization we have today. Of course, it also created its problems. On the left-hand side, you can see the horrible place that used to exist. But that in turn led to the demand for engineers to have better sanitation, better housing, cut out pollution and solve all those problems. And they're still being solved, but that's what it led to. I'm also a member of the Royal Academy of Engineers, and the Royal Academy is promoting several things for young people and for engineering in total. And these two pictures here give you some of the schemes that they run, because they believe that engineers are the basis for building a better world. And that's what we're all in the process of doing. The contributions that we heard this morning on transport, on meeting young people, or on smart systems and on computer systems, all part of building a better world for everyone, a better environment, and a better place to live, and a better standard of living for everyone. We've heard about infrastructure, and that's true. If you look at Manchester now, the urban transport system is nothing like as good as it should be. The transport to local systems, cities like Leeds and Liverpool, is not as good as it should be. The transport to London is only just improving. 15 years ago, there was 1 train an hour to London. Now it's better. And we've heard about the wondrous things technology can do. If Virgin can manage to make the toilets work on their Pendolinos, that will be even better. And I heard with some amusement that great attention is paid to ergonomics on train design. Perhaps you could let the Pendolino engineers into the secrets, because it's not exactly fantastic. However, the infrastructure required in Manchester on renovating the sewers and renovating the urban systems and renovating the transport system and providing a better metro system so we can all work smarter and better and produce less pollution is significant. There's still a huge amount to be done. And as you can see from this picture, there's a vision as well that the technology that we have, our computer systems and smart systems and surveying and all the other applications to engineering, give us wonderful opportunities to do things that were impossible not many years ago. I forgot to mention as well that when I started work there were no ladies engineers, and I think I was telling you before we started that when I was at university there were 125 men in my year, 125 in my year, and the first ever lady in the department. That has changed dramatically, and things are much better now, and I can tell you from my 50 years perspective of work, there's absolutely no reason why women should not be fully engaged in engineering. It's a wonderful career for them, and it's absolutely stupid that the prejudice that used to exist. So if there's any young ladies there who are thinking about going to study engineering, do it. It's a wonderful opportunity for you. The slide here is about one of the problems that we as a whole face, and that is about the environment and the climate. If you think about the challenges that the world faces, one of the biggest is climate change and pollution and all those things that go with it. And in some ways, in some countries it's getting worse. In this country, has significantly improved. If you look at that picture of Manchester at the start of the Industrial Revolution, it was absolutely awful. When I was a child in Manchester, it wasn't a lot better. There were smogs, fogs, pollution, all sorts of things. We have to find a better way of producing good air quality, and that's a challenge for the whole engineering community. It's less pollution from power stations, it's less pollution from cars, it's using the public transport better, it's better heating systems, and a whole scope of issues. The only person that's going to solve it is engineers. Politicians might pontificate and set arguments and set targets and argue about the money, but the technology that's going to do it has to come from us somehow. Another comment that I picked up this morning that I would like to echo is that when you start off in your career, you have absolutely no chance whatsoever of predicting where you're going to end up. When I started as a graduate, I started on conventional concrete and steel designing buildings. I had no idea whatsoever I would end up. I spent a lot of time in the nuclear engineering, and I spent a lot of time designing theme parks and roller coasters. If somebody had told me I would do that at school, I had no idea. So those are some of the jobs that I've had the great good fortune to work on in my career. One of them's the London Eye, one of them's a set of roller coasters, one of them's Wembley Stadium with a moving roof, And all of those jobs involve a mixture of disciplines. They involve civil engineering, structural engineering, mechanical engineering, control engineering, electrical engineering, and architecture, all married together. So whatever discipline you're involved in, you have to have some appreciation of what the other people are doing so that the whole can be put together. And sometimes it's quite amusing. There's another job that I worked on where the dinosaur comes down as you go through on the theme park and he's about to bite your head off. So we heard this morning, you might laugh at this, but you heard this morning how key safety was to everything we do. And that problem of predicting in the nuclear industry or the rail industry about what is safe, what achieves safety, is extremely intellectually challenging and difficult. So when this dinosaur comes down, you've got to be absolutely sure that it stops above your head and doesn't actually go too far and take your head off when it goes through. So the discipline of control engineering, of predicting what might go wrong and how you do that, is not so difficult from the difficulty in rail engineering of predicting what the probability of a crash is, how you operate the signalling system to make sure that doesn't happen, or a nuclear power station of envisaging all the things that might go wrong, of predicting what might go wrong, and of looking at the hazards against that and the mitigation against that. It's a common set of problems, it's a common set of solutions, and it's a discipline that people can absorb, and it's a portable skill. Anyway, it's more fun to design a dinosaur head than it is to design lots of other things. I also work in the defence industry, so I have done historically. And here you can see, I put this slide up, just to illustrate to some of the young people that this marrying together of disciplines is something that you possibly can't envisage when you're a young person. And I encourage you, if you've not started a career, just take some time to look at all the different branches of engineering and think about what the possibilities are and what you might enjoy doing. Because a career is not just about earning money. We all have to earn money, we all have to make a living. But a career is about doing something you enjoy, getting some satisfaction from it, making a contribution to society. So here in the nuclear submarine, I'm sure Barrow is short of workers if anyone wants to go there, but there's a mixture between mechanical, nuclear and naval architecture. And I doubt anybody in this room has considered a career in naval architecture. And there is a shortage. The other thing I can tell you absolutely with my 50 years experience is there's always been a shortage of engineers, and there's always been a shortage of people within engineering of technical ability and willingness to do technical things. And I absolutely guarantee you that will continue. It's not going to change. You need some imagination. These are some pictures from Royal Academy booklet I get every month, illustrating some of the challenges, some of the tasks that engineers have done. On the left is a very innovative lifeboat that now is more unsinkable than before. On the right is this application of engineering technology to helping disabled people to producing better prosthetic limbs and things like that. And there's a whole area of biomedical engineering that improves people's lives enormously. On the left is another innovative machine for the North Sea. But I would also like to raise your gaze about what we're here for. Most of the world still doesn't have a lot of the facilities we've taken for granted. The gentleman previously opened our horizons to the fact that we need to interact with people in Europe. We need to learn from our colleagues in other countries about what to do. But there's whole areas of the world where we as engineers in the West need to help to raise the basic standard of living. Most of the world doesn't have a proper water supply. Go back to the Industrial Revolution in Manchester, the problems of sanitation, the problems of lack of water supply, the problems of pollution in the atmosphere 100 years ago in this city led to thousands and thousands of premature deaths. We're still having premature deaths because of similar problems now and pollution, and there's the recent problems or awareness of diesel fumes and things like that which cause excessive pollution. So the Royal Academy is encouraging people to think about how we might help the third world, how technology can help them, and how we can use the skills that we've achieved. And even in this country, even 150 years after the revolution, the Industrial Revolution, we're still struggling to find homes for people. The government the other week set some target of 1 million new homes. There is absolutely no chance of doing it. We haven't got the technology, we haven't got the resources, we haven't got the skill base, we haven't got people to do it. So people, the structural engineering, civil, have to think, how can we build more homes innovative? How can we do it faster? How can we do it better? Because we have a bigger problem than ever before. So this is another aim of the Royal Academy. How do we harness the technology that we've got to help those who are poorest and most vulnerable? There's a mission to doing it. One of the biggest problems we face is power. Now, the government has promised us that the lights won't go out this Christmas because there's been various deals done to keep things going, but that doesn't solve the basic problem. Mr. Trump might say there's no such thing as global warming and it's all a nasty plot, but actually I don't believe him. There is a problem, and there is a problem that the older power stations produce excessive pollution. We've solved some of it by desulfurization, but we're not going to go back to coal-fired power stations and the like. I would love to believe that wind farms will work. I would love to promote green energy. We should promote green energy. We should be thinking about how we can do it better. But nobody yet knows it's true. We still, because of that, have pollution. We have a lot of pollution, and the UK is about to be fined by the European Commission because, yet again, we have failed to meet the clean air standards, because we produce too much pollution from the cars that we have, from the factories that we produce, things like that. So there's a huge number of things to solve. The picture on the top left is, of course, Fukushima, and the challenge for the nuclear industry, like Mr. Isgar and I used to work in, is how do we produce stations that produce clean energy but are safe? Extremely difficult problem. Picture bottom is, picture there is Hinkley, which is a huge project. If you think about the competition between the demand for engineers for the railway and the demand for engineers for the new nuclear systems that we will need, there will be intense competition because there will not be the resource available to do both. How do we do it? I don't know. We heard this morning about floods. Everybody knows there's more floods. Everybody knows that flooding is a problem, partly because we get more rain, partly because we're building more on land that used to flood. How do we solve the flooding problem? How do we find the resources to do it? How do we stop people being churned out of their homes? Huge problem. I teach seismic engineering at Manchester University, and I start with telling the students how many people have been killed this year in earthquakes. And that's because throughout the world we have mega cities, all more vulnerable. We kill millions, thousands of people every year by the structures that we have falling on them. Huge challenge for engineers to solve. So the Manchester Association of Engineers started in 1856 before there were any other institutions. And they formed because of the sort of thing we've got today, by people who were in engineering in Manchester grouping together and saying that the best thing they could do was share the information and learn from each other. And that's the purpose of all these other institutions that are represented today. They all were spawned by the effects of engineering Manchester. First of all, the Institute of Civil Engineers, followed by the mechanicals, followed by the structurals, chemicals and aeronautical. And they all began as groups of people with a mutual self-interest who wanted to improve their skills, learn from each other, and generally benefit society as a whole. So one other lesson perhaps I'll give you from my 50 years experience is I personally have gained enormously from being involved with these professional institutions, from listening to lectures, from taking part in events, by learning what other people have done, and I heartily endorse that you do the same throughout your career. The Manchester Association has a very long standing. We have lectures. Anybody's welcome to come to them. It doesn't cost you anything. We have lectures on a wide variety of subjects, not particularly specialised in any one. But Manchester is extremely fortunate that it has all these associations who are active and will help you in your careers to learn from what other people have done, to learn what's gone right, to learn what's gone wrong. And I want to just finish on that sort of positive note. There's a whole world to build, and it's still plenty of building to do, and it's your job to go and do it. Thank you very much indeed.